Happy Friday. So today, sorry that I'm not here. I'm at another event this weekend, so I needed to get there today. Today, we're going to be continuing on what we talked about yesterday in class. I also want to remind you, or actually probably even tell you, some of you might not have been here yesterday, that the Ready, Set, Go, your homework for this unit is starting on page 25, and it's going to be number 1 through 18, and that's going to be checked in class on Tuesday. Also, looking ahead to next week, your first formative quiz, is going to be on Wednesday of next week here in class. Just a reminder of the takeaways that we had from yesterday. If you didn't get a chance to write these down yesterday, please write them down now. I will talk through them once again here while you are writing down to make sure that you have them written down, or checking to make sure that you have them written down, all that fun stuff. So a geometric sequence, that's what we started yesterday, is a sequence of numbers with a common ratio between outputs. Okay, so an arithmetic sequence, which we did earlier this week, had a common difference where we added to get to the next term. Here in a geometric, we're going to multiply to find the next term. Okay, so the table showed us yesterday that there was a common ratio of 2. Okay, it showed that we multiplied by 2 to get to the next line. The explicit equation that we found from yesterday's notes is written right there. F of t equals 3 times 2 to the t power. Okay, that's the explicit one. We can use that one, remember, to find any term in our sequence. The recursive equation is going to equal the next term is twice the previous term, or next equals 2 times last, or something along that. Okay? That's the recursive equation. We're multiplying by 2 is the recursive thinking. We're multiplying by 2 to get the next term. Our graph, when we graphed it yesterday, showed us that we had a curved graph as opposed to the straight line graphs that we had earlier in the week. Okay? Change ratio, the pattern of growth of a geometric sequence, okay, otherwise known as the common ratio also, okay, meaning we're either multiplying by 2, dividing by 3, multiplying by 1.5, etc., etc., etc. At this time, we can pause the video if we need to write these down some more. If not, keep going. Okay. Then in your textbooks, there should be a ready for more. I'll give you a couple of seconds to make sure that your textbooks are out and that you can get to this ready for more page. This is on page 23. And what we're going to want to do is we're going to want to write the recursive and explicit equations to model the pattern if the diagram were relabeled in this way. So at 1 minute, we have 3 dots. I always just kind of like to count the dots and see because I can see things in numbers too. We have 3 dots here after 1 minute. After 2 minutes, now we've got 6 dots. After 3 minutes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we have 12 dots. Okay? So we can see a pattern going on there. It appears that we are multiplying by 2. Each and every time. So writing a recursive, what I would like you to do now is I would like you to write a recursive, and while we just wrote the recursive, I should say, we just wrote the recursive and it says that we're multiplying by 2. Oops, grabbed the wrong side. There we go. Oops, went too far. If we wanted to write it as an actual equation, we could say the next term is equal to twice the last term or the previous term. Okay. All right. What I would like you in your tables to do now, and we're going to pause the video here, I would like you to come up with the explicit equation for this one. Pause the video now, please. I'll give the answers in 5 seconds. All right, the explicit I'm going to put it in function notation, so I'm going to go f of t. We're just going to name it something, and my variable is going to be t. I know I've got to be 3 because that's my first term. I know I'm multiplying by 2, so that's going to be 2. Now I've got to come up with that exponent. If I go with 2 to the t power, the first term doesn't work because it becomes 3 times 2 is 6, and I'm off by 1. So I'm going to have to add in here a minus 1 to that. Okay, so that gives me my explicit, and then that fits for all 3 of them. Okay. What I would like you to do now is at your tables, I would like you to turn to page 24 and do all of page 24. Number 1 and 2 on page 24, and we'll come back here when you're done with answers. We'll come back in 5 seconds. All right. So f of 1 means I'm looking on my chart for where we have an x value of 1. That's right there. So f of 1 is negative 13. F of negative 2, I'm going to look down my chart until I find where I've got a negative 2. Happens right there. So f of negative 2 is 8. On the next one, now instead of we're looking for the x value, the input value, that's going to give me an output value of 1. So now I'm going to be looking down the output column for where we find a 1. It's that, so then x here has to equal negative 1. Okay. So if x is 2, then what is f of x minus 1? Well, I would replace 2 for x. So f of 2 minus 1. 2 minus 1 would be 1. So we'd look for f of 1, which we found in letter A, and that is negative 13. Oops, I went a little too far on that one. Fill in the table. So now we're just basically plugging in. So this is going to be negative 4 to the 0 power. Anything to the 0 power is 1. This one is going to be negative 4 to the first power. That's going to be negative 4. This one is going to be negative 4 to the second power, which is negative 4 times negative 4, which is positive 16. This one is going to be negative 4 to the third power, which is negative 4 times negative 4 times negative 4, which is going to be negative 64. And then this last one is going to be negative 4 to the fourth power, which is 256. From here now, you can get questions answered on this if you have them, or you can start the homework, the Ready, Set, Go homework, which is problems 1 through 18, starting on page 25, and that will be due Tuesday. Have a great weekend.